Hi everybody. So I'm going to show you the lab for week 7, which is the lab on measures of variability or measures of variation as they're also called. So we'll begin by the home page for our course, and over on the left hand side you'll see week by week for rest of the semester. So we're going to click on that. We are doing week 7. So we're going to click on week 7, and then we're going to click on the lab for week 7, getting measures of variation in R. So this is a pretty straightforward lab. The opening overview tells you some tips for making graphs to help with your midterm project, and then we're going to review example code for measures of variation in R, interpret it, and then finally knit a Word document. And as a reminder, the Word document will be due on April 10th by 10 p.m. You don't have to submit it at the end of what our class time would be on Saturday the 4th. Okay, so let's go over into Swirl. Log in. 360. And I'm just waiting for it to open. Okay, under Lehman 1 Access, My Apps, and then we'll click on our studio. And now I'm logged in. Usual thing that we always do, you want to go down to the console area and make sure that you are completely out of Swirl. If you're at a cursor like I am, you can try typing the word by, all lowercase with an empty set of parentheses after it. Saying that it could not find the function by is fine. That means we're definitely not in Swirl. If you were in Swirl, you would have a message down here saying leaving Swirl now, type Swirl parentheses to return to Swirl. Or if down here you see a menu with numeric choices for what to do next, you want to choose 0 to get to the next higher level menu, and then you want to choose 0 again to completely exit from the Swirl menu. I have a few different notebooks up here. This looks like where we were last for lab. Okay, so let's see the graphs, and then bar charts and all the nodes and everything. Histogram. Okay, so at the very end of my notebook, which my numbers are going to be different than yours, but for me, the bottom of my notebook is line 466. Wherever the bottom of your notebook is, you want to go down to that end and then go down a couple of lines so you're on a blank line. Then we're going to return over to the lab instructions. Here is the code, and we're going to copy everything. So we're starting at line 1 and copying everything down to line 67. And then once we've copied it, let's go back to our RStudio window and paste it. So if you remember, I said I was around line 466 or so, so let me scroll up. Okay, so this is where we start. So we always want to begin by loading our library. As you can see over here, my environment currently has nothing in it. We want to make sure we're loading the data and all of that. So we'll run our first chunk. And you won't really see anything. Well, it's error messages as usual. But what you should see is your data set showing up over here. and then you should be good to go. If you have a clock that doesn't move and your chunk isn't running, I would say one more time, check that you are out of swirl. Okay, so I know you have your midterm project due tonight on Saturday the 4th, and so I wanted to give a few additional examples of graphs for those of you who are still working on it. One of the things that I told you previously is that if you want to split a title that's long onto 2 lines, you want to use that backslash, or is that a forward slash? Whatever it is, it's the slash that's right above the enter key on your keyboard, and then a lowercase n, where you want to break the title into 2. So here is a histogram for childs, and just again to review what you would want to change if you were making this into your own graph. You would want to change x equals and then type the exact GSS name of your variable in all lowercase. You would want to change the title to reflect what your variable is. You would want to change your label to reflect what variable it is. And you might want to decide on a different bin width than the one that I'm using here. I'm using a bin width of 1, so each bin represents 1 child. So let's run this. And so this shows us that we have the title cut into 2 lines, so it's clear to be seen by everybody. It's a descriptive title, so you know that this graph is about the number of children each person ever had. And you can see each of these represents 1. So people who had 0 children, 1, 2, 3, 4, 5, 6, 7, 8 or more. And so this would be your graph, and then you would write an interpretation of it. You could talk about how it seems like 0 children and 2 children are the biggest categories, how it has a positive skew because you have a few people who have very large numbers of children, but most people have a smaller number. Okay, the other tip that I mentioned previously, but I'm mentioning again here, is if you have a lot of categories in your variable, so something like marital status, religion, astrological sign, you want to make it so that you can clearly read all of the different categories. And the way you do that is by adding the command coord underscore flip with empty parentheses to the very end of your code, right? So I have all of the usual stuff, and then at the very end I have a plus sign and the coord flip. And so if you were changing this to be your variable for a bar chart, which is a little different than the code for a histogram, you would want to replace class here and class here with the exact GSS variable name in all lowercase. You want to replace the title and use title case here, capitalizing and giving a descriptive title. And you want to change the x equals label to describe what your variable is. So let me show you this. And you can see the categories are over here now, and you can clearly read them, and the percentages go here. It's still telling us the same thing. You can say the biggest categories here are working class and middle class. They're both over 40%, and then you have a very small number, less than 10% or less than 5% of lower class and upper class. Okay. All right, so I'm going to stop that here and add a second video where we focus specifically on the measures of variability.